Good morning, students. So today we are going to learn about hybridization, a very important concept for competitive examinations. So before that, I would like to ask one thing. So I put one picture. So I would like to convey some meaning. See, there are some pebbles here, right? Is it pebbles? Yes, they're pebbles. Can we keep these things in this? Let us assume they are small things, small pebbles. Can we keep this in this jar? Can we? It will fit or not? It will go into these gaps, right? Similarly, this sand also will go in. It is much finer than this, right? It may be very small pebbles or some, okay. And this sand is very fine. Yeah. So what is the inner meaning of this is as follows. First thing is, it is our goal, actually. These are extracurricular and co-curricular activities. This will support. That's pretty important, actually. So the main goal should be supported by your extra or co-curricular activities. For example, you're going for jogging or gymnasium. Fine. So, or any sport you're playing cricket or any football or any other thing. Of course, in a pandemic, may not have much options. It's good that you're making an attempt to be physically fit. Right? We recommend to have physical fitness. You can go for a jog. So your physical fitness is going to help or assist or support your learning process better. So that is the main goal is supported. For example, you are a good dancer, or you know the instrumental music, or you know painting, right? Or you know any other extracurricular activity. Fine, no problem. You can practice that. You can practice it. But for example, if it is a dance, again physically and mentally, dance and all requires a lot of concentration, you know very well. A lot of concentration is required for dancing. Similarly, you know, your concentration will be improved, right? For drawing also, you get a lot of skills. So these skills are promoting your career, right? I mean, the main learning process. You're playing chess. So chess is, uh, the, it will stimulate, right? So, or activate the brain muscles, right? So that will help you, like in thinking better, in being more creative, right? In understanding better, in being very sharp, in reciprocating. So, what our main goal is there? So, for example, you have some hobbies. So, these hobbies should support the main goal. This hobby should not take away the time of the, academic part of it. So, for academics, you have time slots, right? So, the academic, whatever time slots you fix, those are consumed by your hobbies or other things. That is not good. Your hobby should promote your main goal. So your hobby should be in such a way, you should choose your hobbies in such a way that should promote the main goal. This is pretty important. Yeah. For example, at night, if you overeat, if you sleep, if you take food at 9 o'clock, how many of you have taken food at after 9 o'clock? Raise your hands, please. How many of you have taken your dinner at 9 o'clock after 9? Raise your hands. Nobody has raised the hand. After 8 o'clock, only 2, 3, 4, 5, 6, 7. Yeah. See, if you take the dinner at 7:30, it get digested by 12 o'clock, and naturally body becomes light. You can wake up easily. If you take food little late, and if you take more food without giving some empty stomach and all, sorry, without half stomach, already I told you how to basically evening and all, always half stomach only you should eat. 1/4 for water, 1/4 for air. That is the best principle, actually. Principles of good eating habits. But if you eat at 9 o'clock and after 9, naturally your body will become very heavy. Even at 6 o'clock also your body becomes heavy. You don't like to wake up. When you take light food, you can wake up easily. Even if you wake up at 3 o'clock, you feel light, right? So what I'm saying is, whatever habits are there, you should promote your academic learning process. You should improve your academic competence. That's pretty important. Yeah. Whatever you do. For example, you are allocating a time slot for YouTube channels to look into many things. Fine, you can look into it. You can see the success stories of some of the IITians, some of the medicos, okay, and about different patterns, questioning patterns, right? And similarly, many things are there you can. So that should promote your career. So whatever activity you're doing or you're designing from morning to evening, that should promote your career. That's pretty important. That will support your learning process. So this is how a wise student will formulate a successful ideology for his or her future. Very important. Yeah. So, for example, some students are there. I will never recommend any student to log on to Facebook, Instagram, or any other social media. That is not good. It is not good for your age, particularly, because you should be mature enough so to deal. Very important. Yeah. Unless you have a proper maturity, so you don't know how to use or how to engage yourself in a proper way, right? So after developing sufficient maturity, so you can use these things for your occupational growth or professional growth or some other personal growth. Very important. You know very well. First of all, you know very well. You have a physical infrastructure, that is body, right? Already conveyed to you. Your this body is sustained by two things. What are those? Anybody? Sharanya? Sharanya, are you there?
Yes, sir.
What are the two things? This body is sustained by dash and dash. Prabhas, 148. The body is sustained by two things. I conveyed earlier. Food and sleep. The body requires food and sleep, right? So when you take the food, listen very carefully. The body takes whatever is required, and remaining it will be thrown out from the body as excretory waste. Okay, very important, right? So the body has a mechanism to accept what is required and to reject what is not required. Similarly, so clean hearts, you have to maintain a clean hearts. So should keep whatever is required and should throw whatever is unwanted. Should keep whatever is required means good things, good qualities should keep. Bad qualities you should remove. Unwanted qualities you should remove. I mean to say, whenever you sow a seed, a tree and all started forming or developing, right, or germinating, and naturally weeds also will come, right? So when you pour water, weeds also will grow parallelly. Do you agree or not? Sharanya,
Yes, sir.
listening. Yeah. naturally you would like to take off the weeds or you want to keep the weeds?
Take off, sir.
You have to take off the weeds. Similarly, so main plant will be affected if you don't take the weeds. So the weeds are like your bad habits or other activities. Okay. So those should be removed. Otherwise, your main desire will be, or main career program will be affected. Very, very important. So, when you are, see, when, for example, daily you'll be exposed to many things. Worldly affairs, I mean to say. Worldly affairs means you are interacting with, at least at home, with your brother, sister, father, mother, grannies, grandpas, uncles. When you come out, you may be interacting with your friends. Of course, over phone also you can do it, the friends and all, the WhatsApp groups and also. Similarly, you have a lot of interactions every day and you cannot keep everything in your heart. So whatever is required only at this age, at this time of, at this time zone, you have to keep. Remaining things you have to clean. Very, very important. So maintaining clean hearts means, particularly as a student, I can refine it. The definition I can refine. So whatever is useful for your academic growth, academic culture, so that you have to keep. Similarly, cleaning your house. So this is an analogy actually. How you keep your house clean. So you have to keep your hearts clean. Hearts clean means keeping the things which promote your academic welfare or well-being. That you have to keep. Remaining things you have to, junky things you have to throw it away. That's pretty important. For example, you got a disturbance with your friend. So switch off it, please. Don't take to the heart. And you have a tendency to compare the marks with others. Please discard. So you have a tendency to take it everything to the heart, discard. You are more sensitive for everything. So try to become insensitive. Okay. So very, very important. So cleanliness of your surroundings and environment is very, very important. It affects a lot. For example, when you are in a temple or any religious place, okay, mosque or a church or a gurudwar, anywhere you are there, what is the kind of feeling you get? You get a purified feeling, a positive energy. You agree or not? May know. Nobody is speaking. Everybody is sleeping.
No, sir.
Yeah. So whenever you go to a religious place, you are having you carry some purifying heart, right?
Yes, sir.
Some positive vibrations,
Yes.
right?
Yes,
So why
sir.
it is so? Because the temples are mostly clean, okay, and there is a positive vibes there, right? So wherever there is a cleanliness, you can experience the positive vibes. That's why, first of all, the body throws off excretory waste when you sleep at night. Okay. So teacher, that's why he suggests you to take bath so that your consciousness will be clean. Very, very important. Yeah. The body. Similarly, so whatever, listen very carefully, whatever in the house, whatever unwanted things are there, you throw it out. Right? You throw it out. The garbage and everything, you throw it out. But you have to have a proper disposal. Very, very important. You cannot throw the things here and there. In the body, whatever waste is there, you are throwing out, right? You're taking bath and yeah. Similarly in the house, similarly in the society, different levels. So try to understand. Ultimately, it affects your. So if you have a positive environment, it makes us active and energetic. Whereas, so if you have a garbage all around, naturally, it makes you to feel dull and lazy. That's pretty important. So that's why it should be the primary responsibility of everyone to keep your heart clean and house clean, at least the room which you are in. So the books, the arrangement should be clean. One more thing I would like to tell you. Many students, they don't write the notes properly. It should be in an organized way, in a clean way. It should be in a proper way. Similarly, when you're presenting in the examination also, it should look clean. Clean in the sense it should be organized. Right? very, very important. So anything you do should be in an artistic way, when you're speaking, right? So, and somebody should love to listen your words, right? So you should speak in such a way with a clean heart. So with a clear vision, very, very important. So that cleanliness is very, very important. When you're dealing with anyone, the cleanliness is important. You should not contaminate the 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 theme of your speech. Very, very important. You cannot try to maneuver others, okay, manipulate others. Should be clean. Very, very important. So these things you try to learn so that you can improve your quality of understanding, quality of learning, quality of thought, and everything. With this note, I would like to start a very important topic, that is hybridization. You know very well, valence bond theory has failed in explaining the bond lengths, bond energy, bond strengths, shapes of the molecules, paramagnetic behavior, and all these things. So valence bond theory failed, right? So naturally, let us see beryllium chloride example. So this is beryllium chloride, how it looks. Now, what is the formula of beryllium chloride, anyone?
PeCl2, sir.
PeCl2.
Yes, BeCl2, right? So it is made up of two. It is connected with two chlorines, right? Beryllium and chlorine. This chlorine. So one is a gas, right? Chlorine is a gas, yellowish gas, yellowish green, chlorine color. Yeah. You know the electronic configuration of BeCl2. So it is 1s2, 2s2. There is no unpaired electrons, right? So the question is, according to valence bond theory, there should be parallel and anti-parallel spins, right? So how it is possible? In order to get the octet, you should have 4 bonds. So that's why excited state is suggested. What is suggested? Excited state. So let us see how excited state and all happens. For example, yeah. You can see here beryllium. I'm writing only outermost only. So 2s2 is there. This gets excited here. So one electron gets excited here. Now 2 chlorines, it can form bond. See? So this excited state is suggested. Yeah. So this is ammonia, right? What is the expected bond angle? 90 degrees. But it is not 90 degrees, it is 107 degrees. Why? We'll see all these things. The shape is pyramidal shape. Ammonia is pyramidal shape. It is not T shape. So 101.7 picometers is there. This bond length is not given by VBT. Bond angle is not given by VBT, right? So try to understand. So we learn all these things. Water also similarly. The structure is not given by VBT. It should be 180 bond angle, but its bond angle is only 104 degrees, right? And its shape is not linear, it is angular structure. So this angular structure this way, it is 104 degrees. So how can we explain the shapes of such molecules like water, ammonia, and so on, and its bond angles, bond lengths? So this is what hybridization is going to talk about. So valence bond theory has not explained all these things. Why it is linear? Why BaCl2 is linear? It is not explained. What is the bond angle? It's not explained. Why BF3 is planar? It's not explained. Similarly, why CH4 is tetrahedral geometry? So there is no explanation from valence bond theory. So similarly, why ammonia is pyramidal? No explanation. And what is its bond angle in ammonia? No explanation. Similarly, what is the shape of water molecule? No explanation. So shapes, bond angles, bond lengths, bond strengths. So magnetic behavior has not been explained by valence bond theory. Now, a new theory has been introduced by Linus Pauling. The Pauling is the same Pauling who has introduced electronegativity concept. Yeah, 1931. So he is the grandpa, looking smart. And he is the one. So who defined hybridization as follows? The process of intermixing of the orbitals of an atom having nearly same energy to form same number of new set of identical orbitals. That is called hybridization. So how to understand this definition? So let us understand part by part. First part is intermixing of atomic orbitals. For example, beryllium is there. Beryllium is having two s, 2p orbitals, right? They get intermixed. Just now you have seen 1s2, 2s2, 2p, 2p. But 1s2, 2s2 is electronic configuration. 1s we don't use. I'll teach you again. See, in beryllium, you have 1s2, 2s2. Outermost is what? 2s2 only. So let us write outermost only always. Now, when you excite B star, what happens? 2s1, 2p1 it will become. This is the one. Now, you have an s orbital. You have an s orbital. This is 2s. You have a p orbital. These two, this one. They get intermixed. They get intermixed. These two because intermixing. So intermixing of what? Atomic orbitals. S and P. Of what? Beryllium. Of beryllium. See. Having same energy. Same energy means what? 2s and 2p have same energy. More or less. Because they're in the same orbit. It's 2s and they give a new set. This is the hybrid formed. So hybrid, linear hybrid is formed. This intermixing leads to hybrid. We'll see all these things. So the phenomenon is called hybridization. You can see here, there is a S and P orbital and equal number of hybrids will be formed. Now let us see. Listen very carefully. Again, it's an orbital concept. It is not electrons. It is intermixing of the orbitals, right? So it is orbitals only. Now very important. The number of hybrid orbitals is equal to number of atomic orbitals gets hybridized. For example, listen very carefully. If you combine 1s, 1px, 1py, py orbital, they get intermixed and forms and gives rise to a hybrid. So the hybrid is, so now this is the hybrid. So they're having equal number of atomic orbitals. So this is the hybrid 3. Here 1, 2, 3, here 3 lobes you got. Similarly, if you use like another one, like PZ orbital, then you get tetrahedral structure. Tetrahedral structure. So try to understand. So equal number of hybrids will be formed. Here 4 hybrids are there, 4 sp3 hybrids. This is sp3, this is sp3, this is sp3, this is sp3. So here this is py, pz. So here this is sp2 hybrid. Only because only these 3 are participating. this sp2 hybrid. This is sp2 hybrid. So if you only 1s and 1s and 1p, it forms sp hybrid. This is sp hybrid is formed. So number of sp hybrids are 2. Number of orbitals, these are atomic orbitals. These are hybrids. So hybrids here are 4. Orbitals are also 4. Here hybrids are 3. So atomic orbitals are 3 only. Hope you are clear. So some important things. The 2 important things are there. One is they should be of similar energy. For example, you can mix a 2s and a 4p. You can mix. Okay. 2s, 2p you can mix. 2s, 3p you cannot mix. Try to understand. Because they are not of the same energy. Know what are the energy levels given by Hofbauer. Now listen very carefully. Listen very carefully. Very important thing. This one, sigma bonds. I'm writing one statement here. Pi bonds don't participate in hybridization. I mean to say pi bonds should not be considered for hybridization. That is a better word. Pi bonds shouldn't be considered for hybridization. So we should not consider pi bonds for hybridization. Very, very important. Now, well, already conveyed to you. Only valence shell orbitals only will be participating. For example, beryllium. Beryllium is like this. 1s, 2s, 2p. Right? What is the valence shell here? The valence shell is, this is the valence shell, right? Last shell. That means these will be participating. Okay. For example, take here 3s, 3p, 3d. Here valence shell, these 3 will be participating because that is the valence shell. Right? Yeah. These are some of the postulates of hybridization. Now, very, very important. Promotion of electron is not an essential condition. Try to understand, very important point. See, sometimes you write the excited state. See, carbon you take, for example. Carbon. What is the ground state of carbon? Srikar. Srikar, are you sleeping? So, 1, 2. This is the ground state of carbon. 2s2, 2p2. Am I right? Right or wrong?
Yes, sir.
How it is right? Pauli's exclusion principle is missing. Here it is there.
Sir, it should be filled in the
Sir, it
next
should be
one.
placed in second one.
Now listen carefully. C star. C star means what?
Excited state, sir.
Excellent. Excited state. Now, we keep the electron here. This gets excited. Now, listen carefully. Here, the essential condition is you may promote the electron, that is excited state. Sometimes excited state may not be required. So, it is not a necessary condition. That's what the promotion of an electron, that is the excited state, may not be a necessary condition. It may be, may not be. That is the meaning here you have to derive. Next. It is not necessary only half-filled orbitals participate in hybridization. No, not required. Okay. Because valence bond theory said actually this part. So Pauli's and Hund's rule, you got to follow. Right. So these are some of the things associated with hybridization. Right. So let us see some of the questions, simple questions. What is the answer in this?
Sir, all of the above, sir.
All of the above, sir.
Listen very carefully. Hybridization is meant for only sigma bonds. It is not pi bonds. So pi bond should not be taken into consideration in hybridization concept. Yeah. So orbitals are of same energy or equal energy will be participating, get intermixed to form hybrids. Next. Hybridization is for only orbitals. It is not for electrons. Fine. Next. So what hybridization is going to explain? Come on.
Both bond angle and
Sir, both
geometry, sir.
bond angle
Both
and
bond
geometry.
angle and geometry, sir.
Very good. Nice. Next. Let us see. Now we are getting into the core. Okay. Listen very carefully. Hybridization is very important for complex exams. First, there are different types of hybridization. One is SP hybridization. I'll give you the hybridization. SP hybridization. SP2, SP3, SP3D, SP3D2, SP3D3. So here, students, so how I'll show you what type of orbitals are participating here. 1s, 1p, sp, s and p. Here 1s, 1px, 1py will be participating. That is sp2. In sp3, 1s orbital, px orbital, py orbital, pz orbital will be participating. Yes, p3. Okay. Next, sp3d. So 1s orbital, 1px, 1py, 1pz. Next, 1d orbital will be participating. Next, sp3d2. So 1s orbital, p3. P3 means px, py, and pz. And then d2. It may be dz square also, dx square minus y square also. Or it may participate sp3d3. Next, px, py, pz. d3 means what? It may be dxy, dyz, dzx, xy, dvz. So these will be participating. Listen very carefully. These are the atomic orbitals. The atom is having orbitals. These atomic orbitals gets intermixed to give hybrids. So let us see how they give. So far you understood?
Yes, sir.
Fine. Let us see sp hybridization. Already conveyed to you. In sp hybridization, there is intermixing of one s orbital and one p orbital and lead to the formation of sp hybrids with linear shape. The bond angle 180 degrees. Now, shape is linear, bond angle is 180 degrees. Number of sigma bonds is 2. So, whenever there is a intermixing of one s orbital and one p orbital, it leads to the formation of a linear structure with 180 degrees bond angle. Right. So let us see how the intermixing takes place. Listen very carefully. Listen very carefully. Yes, 1 second. I'll take annotation so that. See, SP. In SP hybridization, 50% is S character, 50% is P. Right only, no, only two are there. For example, SP2. Can you tell me? In
Sir,
SP2.
mostly
25%
33 and
is
60. Sir, 33 and
33.3,
60%.
66.6%. This is S character and this is P character. Now SP3, can you tell me?
Sir,
25%.
25 and 75, sir.
75%. So like this, you have to understand. Now, sigma bonds are 2, let us see. There is a percentage of p character, 50. Now, this is s orbital. Now, this is a px orbital. These are the atomic orbitals of a particular atom. Gets intermixed, hybridized, combined. It forms a hybrid. Two sp hybrids are formed. Hello, listen carefully. Two sp, this is one sp hybrid, this is an sp. So these will form like this. This will combine, here this will combine and forms like this. So this is called sp hybrid. And what is the bond angle of sp hybrid?
180, sir.
180 degrees, sir.
Yes, bond angle is 90 degrees. And what structure is it?
Linear, sir.
Linear, sir.
Yes, you can see 180 degrees. It's having a linear geometry. Right? Yeah. Now, listen very careful. Example, beryllium chloride. See, beryllium is a central atom. Listen very carefully. Now, this B, now you can excite one electron. This is 1s2. So this is 2s2. This electron can be excited. So 2p0 initially. Right. Now I excited C. Excited one electron from, yeah. Now what happens? Listen very carefully. Listen very carefully. This s orbital and this p orbital gets intermixed and gives rise to a hybrid. Okay. For example, let us take the formation of BeH2. So what happens? Beryllium is like this and hybrid is formed like this. And now hydrogens will BeH2. Listen very carefully. BeH2, hydrogen will combine like this. Now listen carefully. It is sp, yes. This is sp, yes. The sp is the hybrid of beryllium. Hydrogen is, yes. S orbital will be combining. Similarly, this is a beryllium. 1 second, I'll just rub it off. Yeah. Now listen carefully. For example, BeCl2. Beryllium hybrid is, this is the hybrid, sp hybrid. Now, combined with how many chlorines? For example, this is the hybrid. Listen carefully. This is the hybrid. What hybrid? sp hybrid. Now, 2 chlorines are combining. Now, what happens? Let us see. Now, listen very carefully. Now, this will form you can see here. So this bond angle is 180 degrees. How? BeCl, Cl, the bond angle 180 degrees. Any problem now? Any doubt? Similarly, BeF2. So, try to understand, students. It is BeCl2, BeH2, BeCl2. They're having their isostructural. Isostructural means what? Iso means same. Structure means same structure. So they are isostructural. Anyhow, this is all about sp hybridization. So 1s orbital. Now, it should be excitation to the p orbital here. So here the s electron gets excited. Now listen carefully. Now today I'll outline, tomorrow I explain more examples. Tomorrow's class is very important. Now let us take sp2 hybridization. sp2. In sp2 hybridization, there is intermixing of 1s orbital and 2p orbitals. They combine 3 equivalent hybrids. See, here they form a trigonal structure. See, 1s orbital and 1 p orbital, another p orbital, 2 p orbitals, right? they get intermixed and forms a hybrid. So what hybrid? sp3 hybrid. This is one sp2. The other 3 hybrids are formed. Hope you are clear. The 120 degrees bond angle. Example. I'll give some number of examples I can give. I'm writing here. BH3, BF3, BCl3, BBr3, and so on. They're all having bond angle of 120 degrees and sp2 hybridization. So number of atoms is 1, boron 3 fluorines. So let us see how it works. This fluorine requires 1 electron. Boron, see. But boron only one can accommodate, form only one bond. So you have to excite it. So you excite it, see here. Excite it. When you excite, what happens? So 3 are there. So BCl3, BH3, BF3. So each will, see, it is not here electron share, it is not electron sharing. Okay. These will form a hybrid first. Yes, sir. P2. These 3 will form a hybrid. So this is the hybrid it is formed. Clear or not? Now to this hybrid BF3, listen very carefully. I just see these are how pure F orbitals. This is BF3 structure. I mean to say, I'll tell you in a more clear way. So this is boron, this is sp2 hybrid. If you want to write the structure for BH3, H3, listen carefully. Hydrogen, hydrogen, hydrogen. So this is sp2s. This is sp2s. Because sp2 is the hybrid. sp2s. Now, if you want to write for BF3 or BCl3, I can take here boron. Now, you can write like this. Agreed or not?
Yes, sir.
This is Cl or F. Let us take X is equal to F or Cl. Yeah. So now we can see clearly it is having what structure? What is the bond angle here?
120 degrees, sir.
Yes. It's a trigonal planar system. B F3 having 120 degrees bond angle with the TP. TP means trigonal planar. Trigonal planar geometry. So this is how wonderfully you can explain the formation of BCl3, BF3, BH3, AlCl3 systems. These are fluorines you can see here. So it is orbital concept, hybrids, 120 degrees bond angle. Yeah. So shape is diagonal planar, bond angle 120, percentage S character is 33.3, percentage P character is 66.67. So sigma bonds are 3, pi bonds are 0. Type of overlapping is sp2p. In BH3, it is sp2s. Right? Right only, na? Fluorine p orbital is combining. So these are some of the examples. Tomorrow I'll explain these examples. Today I'm outlining what is hybridization. Now what is percentage P character here?
66.67%.
6.6. sp2. S character is 33.37. What type of overlapping exists? Can anybody tell me?
sp2s, sir.
sp2fp, sir.
sp2p.
sp2p, sir.
Very good. sp2p. Because fluorine is having p orbital, right? So what about C2H4? You may not be knowing. This I'll teach you tomorrow.
sp2p, sir.
It is sp2h. sp2s,
S,
sp2s, sp2s. Tomorrow I'll explain this. Very important. Tomorrow is pure applications. Next, BF3. What is the bond angle?
120
120
degrees, sir.
degrees, sir.
That's it. Very good. 120 degrees. So let us see sp3 hybridization. Okay. Now, in this hybridization, one s orbital and three p orbitals will be forming. One s orbital, three p orbitals. They give equivalent sp3 hybrids forming a tetrahedral shape. So one s orbital, one p orbital, another p orbital, another p orbital. These are all three p orbitals. They combine and forms a tetrahedral geometry. These are the hybrids. The hybrids. And after intermixing, you get the hybrids. So four sp3 hybrids are formed. So the four sp3 hybrids will lead to the formation of tetrahedral structure. CH4, CCl4 is an example. So hope it is a tetrahedral geometry. So what is the bond angle? Anyone?
Sir, 90
not-
degrees.
No. 109 degrees,
109.
28 minutes. So you have to know, you have to remember this. The bond angle in sp3 hybridization is 109 degrees, 28 minutes. So example, ammonia. These are the ammonia. 1s orbital, the p orbitals are combining and forms four sp3 hybrid orbitals. You can see ammonia. This I'll explain. Lone pair repulsions I'll explain. Don't worry. Lone pair bond pair repulsions also I'll explain. Okay. Yeah. So shape of the ammonia molecule is pyramidal, not tetrahedral. Pyramidal I'll explain in the next session. So how this is how here lone pair will be there. This lone pair will sit here. How lone pair and all I'll teach you now here, right now. Have a look. So nitrogen is like this. Listen very carefully. What is the outermost electronic configuration of nitrogen? Help me. 2s2,
P5.
2s2
2p3. Good. Now
2p3.
listen carefully. This hydrogen participating, sharing. No need of any excitation. Can you see here what is this called? What is this
Lone
called?
pairs. Lone pairs.
This is the lone pair. And here hydrogens are to the tetrahedral only. Listen very carefully. Here one hydrogen, here one hydrogen, here one hydrogen. Here,
Lone pairs, sir.
so leading to, is it not a pyramidal geometry? Pyramid. Agreed or not?
Yes, sir.
Yeah, it is having a pyramidal shape. So here the bond angle is 107, not 109. Why? I'll teach you tomorrow. Okay. There is a repulsions are there. This is a lone pair. I can teach you right now, but I'll teach you tomorrow also. See, listen. This is a lone pair. They are the bond pairs. See, try to understand. See, lone pair means what? Non-bonding electrons, right? These are bond pairs, right? Listen very carefully. These are bond pairs. This is LP. Now listen. I'm writing here. LP is non-directional. Non-directional means what? It
is
can
not
move. It can move here and
can
there. It can move like this. But bond pairs are
directional, sir.
they are directional. So there is a repulsion. These will repel these bond pairs. So bond angle decreases. So there is a LP-BP repulsion. What repulsion? Lone
Lone
pair,
pair bond.
bond pair
bond
repulsion.
pair
Bond
repulsion.
angle will decrease from 109 degrees 28 minutes to 107 degrees due to lone pair bond pair repulsion. That's it. Nothing more. So that is ammonia molecule. Shape is pyramidal. What is the percentage of S character in sp3?
25%.
25.
sir.
P character is, and sigma bonds are 3. Ammonia sigma bonds are 3. Pi bonds are 0. Right. So these are all about the sp3 hybridization. Now you have learned 3 types of hybridization today. One is sp, one is sp2, one is sp3. So here you have linear shape with a bond angle 180 degrees. Here you have a trigonal planar with a bond angle 120 degrees.
120 degrees, sir.
Here you have a tetrahedral with a bond angle 109 degrees, 28 minutes. So here you have seen some examples like BH2, BeCl2, BF2, etc. In sp3 you have seen some examples like BH3, BCl3, etc. sp3 you can have CH4, CCl4, SaH4, etc. So these are all about the basics only, not competitive depth. So tomorrow I'm going to take you to the competitive depth. Tomorrow class is little complicated class. Easy only, but you have to focus. So any doubts? I open the session for discussion.
Sir, actually, can you explain the structure of loose dot structure of ClO2, sir?
Okay. See, this is chlorine. This is oxygen. This is oxygen. Now, is it Silpita?
Yes, sir.
Now, what is the valency of chlorine?
7,
1,
sir.
2, 3, 4, 5, 6, 7. Clear? Now, oxygen requires how many electrons?
2, sir.
This oxygen requires?
2, sir.
Very good. Chlorine can share maximum? 1 only, na?
2.
1 only, na? Chlorine is 7, na? 7 valence electrons are there for chlorine. That means it can
Yes,
share
sir.
only with 1 only. But if it shares 1, will it accept? Oxygen, this oxygen will accept or not? No.
Yes.
Oxygen will not accept, na? What is the reason? Because you don't
Sir,
get the
because-
oxygen. So that's why it forms a day2 bond here. It forms a day2 bond. This is day2. Day2 means what? This chlorine is donating this to the oxygen. Are you following?
Yes, sir.
Here also day2 bond only it will form. See. Day2 bond only. Now there is a lone pair here and one unpaired electron. This is unpaired electron. See, octet is not satisfied. Chlorine is having 7 electrons. Oxygen is 8. This is also 8. Clear?
Yes, sir. Sir, the dative bond is for 2 electrons, sir.
The day2 bond is these 2 electrons are belongs to chlorine and is donation and sharing. Similarly, these 2 electrons also belongs to chlorine and donation and sharing.
Yes, sir. Clear, sir.
That's why it is paramagnetic because there is one unpaired electron. Odd electron species. These are odd electron species. Any other doubts, please? No doubts. So thanks for bearing. Have a good day.
Thank you.